and share screen. Okay, so I'll just repeat one more time. When a question asks you to solve an equation, it's asking you for the x given the y. I'll say it better. When a question is asking you to solve a question, to solve for x, they will give you the value of y. They'll give you the answer. They're asking you, what is the value that got me this answer? They'll give you the y, and they're asking for the x that got me the y. It's sort of like reverse. Normally, a K-style question would be, I give you the x, you plug it in, and you get me the y. You know how to calculate using functions. But the reverse is usually the case in life, right? Here's a scenario. This is what happened. What caused it? That's always sort of the case. So there's going to be a couple of different scenarios that you're going to run into. And that is, sometimes you will find two different possibilities. Sometimes you'll have one possibility. Or sometimes you'll have no possibilities. In other words, two answers, one answer, or no answers. One scenario, when you're calculating it, the parabola can look something like this. Or, of course, upside down, it could look something like that. A parabola like this will have two x-intercepts, or two roots. And so we call them, these situations, we would have two distinct or different real roots. They exist, they're real, and they're distinct because they're different. Sometimes the parabola, or whatever the question we're dealing with, will have only one possibility. Graphically, it looks something like this. It will only touch the x-axis once. We could call this one root, but the proper mathematical way of describing it is it's two equal roots. Oh man, they are going outside. Would you guys prefer taking a walk outside? Yes? Okay, who says they don't mind the cold? All right. Who would rather stay away from the cold? Oh, it's like perfectly split. We'll see. Maybe we'll roll the dice one day, okay? All right. And lastly, if the answer is impossible, in other words, there is no way you could have gotten something, there are parabolas that don't even touch the x-axis. And so we have no real roots. Those are the three different scenarios you can come by. And our goal today is, using the quadratic formula, identify whether it's two possibilities, one possibility, or none. Yes?
I'm confused as to why it's two equal real. Is it just because you drew two parabolas?
No. Think about it. Think about it like this. Think about it like, just in case someone is watching. Let's see. Pause share. And can I go back to just? One second. Sure. Yeah. Think about it like this. This might help in grade 12. If a parabola is here, I would have two roots. But if the parabola was slightly raised, do you notice how the roots are now closer together? And if this was slightly raised even more, the two parabolas are closer together. If I continue to raising it, what happens to the two dots? They will come together. Think about it like that, okay? Yes, it's one point, but that is because the plus and minus, like the 2 points that are coming closer and closer to the axis of symmetry, simply are overlapping each other. So you can think about it like that, okay? I hope that sort of makes sense. Let's share screen again. That all disappeared. Sorry about that. But that's okay. Okay, let's continue moving. So, when you're solving for a quadratic, or solving for the roots, up until now, I always ask you to factor, right? and then you find the zeros, whatever the x value is that makes it a 0 is your answer. There will be cases when you cannot factor. And so that is when you use this thing called the quadratic formula. Okay? And how does this quadratic formula link to the 3 pictures that I just drew? I'll make a little note here. Okay? Very, very small, but definitely there. You will see in the quadratic formula that there is a plus or a minus section. Okay? Now we'll say a plus or minus will provide 2 different answers. If you add something, it increases the value. If you subtract something, it will decrease the value. The negative b over 2a will give you a number, and then if you add that square root to it, it will increase the value, or if I subtract it, it will decrease the value. Long story short, the negative b over 2a represents the axis of symmetry. And if you add more to it, it gives you the x-axis here, x-intercept here. If you subtract it, it'll give you the x-intercept there. That's all it is. Okay? So let's see how let's see it in action. So the plus minus will provide 2 possible zeros or roots in this case. Okay? A couple of 2 stars I want to add. Star number 1. If the square root portion equals a 0, then plus minus 0 doesn't change the value. Doesn't change the, I guess, the calculated value of negative b over 2a, right? So if the square root portion is a 0, there's only one answer. So in other words, one root. Put another star here, double star. If the square root happens to have a negative number underneath, then what? Yeah? Yeah, we can't solve it. You can't square root a negative number. So we know that impossible to solve. In other words, so no answer exists. So the quadratic formula does more than give you two possible roots, 2 x-intercepts. Just from looking at the square root portion, we know that if there is going to be an answer or not. So my recommendation, my suggestion, my request to you is even before you try to calculate the entire formula, test the square root portion first. The square root portion, it's a root, and so we will bring back the term radicand, but because this is such a special circumstance, the square root gives us so much more information. We give it a new name. The square root portion is called the discriminant because it will discriminate between or categorize between one of 3 different situations. Right? The root word discrimination. We use discrimination in a negative way, but the root word for that generally is categorizing, right? Is judging or is compartmentalizing between different things, between different groups. So, let's test it. Should I pause or everyone's okay with this? Maybe once and twice? All right, let's go. So, I'm going to give you 1 type of example, 2 types of examples, and then 3 types of examples. The first one is simple. If you can solve it directly without the quadratic formula, do it. If I give you something like this and I say, hey, what's the solution? AKA, if that's the y value, what's the x? You don't even need to factor, you can solve it directly, like so. It's basic algebra, right? How do I get x all alone? Well, let's add 12 and add 12. And then, let's get people awake. Let's start with Zane's row. What's next, Zane? What's next? How do I get x all alone? We want to get rid of the coefficient, the 2. So we're going to divide both sides by 2, leaving me a 6. All right, let's keep moving. Louisa, what's next? Right? Which will give me either a positive or a negative value, of course. Right? So what numbers satisfy this entire equation? It could be a root 6 or a negative root 6. No factoring involved, no quadratic formula involved, no nothing involved, okay? Next, how about this? If it's in vertex form, Lucas, what comes first?
Um,
That's okay. But this is what is it? Trying to get x all alone. So some people can think about the algebra as reverse BEDMAS, adding and subtraction first. Let's get rid of that subtraction. Plus 5 plus 5. Next comes multiplication division. Are you with us? What's next?
You want to divide 1 over 2 and 5.
Sure. So I could divide 1 over 2 and divide 1 over 2 is the same as multiplying, so we get a 10. Great. Nathan?
From there, you multiply the x minus 6 times 2.
Oh, this is a square.
X minus 6 times x minus 6.
Right. I want to actually get x all alone. So how do I get rid of a square on the left side? Nathan? What's the opposite of a square?
Opposite square would be square root.
Square root. So if I square root both sides, I get plus minus 10. And then all that's left is a negative 6. Clara? Yeah. So this is a positive 6 plus minus root 10. What does that mean? Again, remember, this is the y value. It means when x equals a 6 plus a root 10, my y value could be 0. Or if this is a 6 minus a root 10, my y value could be a 0. In the same way, I'll go back to the first one. If my x is a root 6, my y value is a 0. And if my x is a negative root 6, my y value would be a 0. That's essentially what we're trying to find. That's what we did. No factoring, no formula, no nothing. But as the situations get a little bit more confusing, it is up to you to develop the eye and figure out what you think is the best solution for this. So, number 2, if the equation could be factored, it's probably the better way to go to find your solution. So the y value is 0. I see all of these are multiple of 2. I'm going to factor a negative 2 out first. I think that's easiest. 108. And this is supposed to be simple trinomial factoring. So there are 2 numbers that multiply to negative 108 but add to a negative 3. I'll give you a second. See if you can find 2 numbers that multiply to 108. But because it adds to a negative 3, those 2 numbers are probably pretty close together. Go for it, Emily. Keep going. Try to find it for us. One of them is a... If it was a 6, I think you got 6 and 18. That would be too far apart. It wouldn't give us a negative 3. But good try. What's next? Not 6. Try a higher number. Yeah. Negative 12 plus 9. They add to negative 3, but they will multiply to a negative 108. So my x value is a 12 when giving me a 0, or my x value could be a negative 9. The two roots, the two x-intercepts are that. And of course, you don't need to write those points. I just want to make the connection of why we're factoring and what it is that we're arriving to. Why is this helpful to us, right? Our previous lesson was always about the max. This lesson is always about the 2 points on the x-axis. Next, this one's a complex one. We have two numbers that multiply to negative 24 but add to a 5, 12, 2? No, 8, 3. It would be a positive 8 and a negative 3. 3, no. 2x, 3x plus 4, minus 1, 3x plus 4. So my factored form is not the prettiest, but the process is still the same. That means x is going to be negative 4 over 3 or a positive 1 over 2 when y is a 0. Did I do that right? It multiplies to negative 24 but adds to 5. My answer key for this one is not correct. I did it right here and I did it wrong. That's crazy. Okay. All right. So factoring. The next two examples, you will notice that you cannot factor. I made the numbers intentionally a little bit nasty so that you can't find the a rounded number, but they'll give you practice leaving it in radical form, okay? You're going to leave it in square root form. You'll see what I mean. Okay, part one. If you can't factor it, first test the discriminant. Test to see what situation it is. Is it 2, 1, or 0? Because if it's 0, if you get the inside portion to be a negative, you don't have to do any more calculations. You're done. Because you can't go any further. Let's test it. The b version is b squared, so 8 squared, 64, minus 4 times a negative 10. 64 plus 160, so that is 240, 224. Which I can factor out a 16, so that turns into a 4. 4 root 12. No, 4 root 14. Okay, it's a positive. So I know that there's going to be two answers. X is going to be equal to, remember, negative b plus minus the discriminant portion over 2a. The reason I ask you to do the discriminant first is after you do that, you won't have to write it again. Negative b plus minus 4 root 14 over 2a, which is 8. And I'm going to reduce it to divide everything by a 4. There you go. What does that mean? Just like before, it means that if the x value is negative 2 plus root 14 over 2, the y value is a 0. Or if the x value is negative 2 minus root 14 over 2, the y value is a 0. Whew. You can try that on your own. I don't think I have to beat a dead horse for you to understand, like, you first check the discriminant, right? To see if it's even doable, and then once you notice that you have to do it, then you just do it. Do your best. Your radical practice will come in handy here. You'll be able to simplify that radical as best you can. Are you wrong if you leave it as root 224? You're not necessarily wrong, but it's not in simplest form. I would have little choice but to take off communication marks or something if this was a test. Okay? It's important, unfortunately. It will be labeled bad form, EF. Any questions? Yep.
So in A,
Mm-hmm.
how did you get the B value? Is that from the equation at the top?
Yes. Yes, sorry, I must have jumped the gun. So by default, the first variable is an A, the second variable is B, and the third variable, the first coefficient is A, second coefficient B, and the constant is a C. So those numbers are what you plug into the quadratic formula, ABC.
Would it be different if you put minus 10 plus 8x instead of plus 8x?
No, the A value is always with the x squared. So even if it's negative 10 plus 8x plus 4x squared, right? This is still the A value because it's with the x squared variable.
Okay, but what about the, and the B is still B because of GS?
Yes, that would be B and that would be C. C is always the constant. The last letter is always the constant one without the variables. Okay? Any other questions? Yep, Nathan?
For root b, did you say if we hit a negative square root, then
Yes. So let's try it. So b squared minus 4ac, that's negative 11 squared. Negative 11 times negative 11 is actually a positive 121. Minus 4 times a times c, so we have 121 minus 24. The answer to the discriminant is 97. It's a positive number. So there are two solutions. Okay? Let's try that. So it's 11 o'clock. A quick recap. There is one question on the very bottom, just to show you how intricate the questions can get, and it's only going to ramp up from here. 1.3 showed you how to get the highest or the lowest point. 1.5 shows you how to get the x-intercepts. Both of these are going to be useful sometime in the future. But those x-intercepts don't have to necessarily be, those roots don't have to be the x-intercept. So this is going to be an example where, here's an example where, as I said earlier today, the roots are not the x-intercepts for this situation, but it helps us with the calculation. Here we go. This is an example of a cannonball, sort of like trying to shoot an arrow to a dragon example. Height of a cannonball is given by the function h of t, where it's 10 plus 30t minus 5t squared. How long is it? So assuming t is time. How long is it above a height of 35 meters? I'll let that sink in for a second. I'm not asking when the height is 0. I'm not asking when the cannonball hits the ground. When is it above a height of 35 meters? A lot of people are brain dead, so let me show you. Okay? Like, you guys are getting tired. Here. Start with that. I want to know when the cannonball hits 35 meters. Doesn't that make sense? If I want to know when it's above it, tell me when it actually hits a height of 35. Because visually, because I'm actually a really visual person, I'm assuming the parabola is going to be like something like this, right? And it's going to hit the ground somewhere. But at a certain point, at a height of 35, the cannonball will cross and go upwards, and then whatever goes up must come down, so it's going to hit 35 again. I'm going to predict that if it does hit 35, I'm going to get two answers. One on the way up and one on the way down. Okay? So if I have 35 as my height, and that's equal to 30t minus 5t squared, let me rearrange that into negative 5t squared plus 30t plus 10. The question is, what's t?
I just have a question. So if it just raised 35, and then like the vertex would be 35?
Oh, yeah. Yep.
Instead of 2 being like plus or minus a tiny decimal?
No, it would be plus or minus 0 if it's only exactly 1 point. Yeah. Or, you know what, I might give you a trick question. Maybe the 35 mark is here and the parabola is like that. You don't know, right? I could be mean like that. Whichever. Okay, how do I erase this? All right. Let's do this. Okay, so what is t? Well, we don't have any good solution when you have a value, but I'm going to manipulate it and pretend that I am calculating the x-intercepts of this equation instead. Pure number manipulation. I have to work with this equation, but I'm going to pretend I'm working with this equation when the height is equal to 0. You see what I'm doing? I'm just moving it over. And so let's do it. Kiara, I'm going to give you the option of choosing. Do you want to factor? Do you want to use quadratic formula? What would you prefer? Factor. Let's do that. They're all multiples of 5, so I'm going to factor this out first. Minus 6t plus 5. Would you do the honors? Kiara, what numbers multiply to a 5 but add to a negative 6? There aren't too many numbers that multiply to 5. But because it adds to a negative 6, the answer must be negative 1 and negative 5. They multiply to 5 but add to a negative 6. So, what are the two possibilities of t? This is really, really important right here. When t equals 1, it makes this function equal to 0. When t equals 5, it makes this function equal to 0. When t equals 1, it makes this function equal to 35. And when t equals 5, it makes that function equal to 35. This and this is the same equation, but I can factor and do all of this junk because the y value equals to 0. That's all it is. That's why we are always making the one side equal to 0 and doing the factoring stuff. But these two are basically the same thing. So whatever answer I get for the black one, I can also use for the blue one. because they're one and the same. And so, what does that mean? When time equals 1, or when time equals 5, I hit 35 meters. Let's go back to the question. How long is it above 35? 5 minus 1, 4 seconds. Therefore, the ball is above 35 meters for 4 seconds. Wow. I know that's a lot. But again, being grade 11 functions, all of this was taught over a full chapter. So we basically did an entire grade 10 chapter in a sitting. So hopefully it's review, but if it is not, don't feel intimidated that it might be a little overwhelming. Just keep on working on it and catch up. Okay? You may not, right now you might be angry at your past self, right? Like, my past self is always leaving work for my future self, is what I'm saying. But do what you can. As always, there are example questions that you can use. Numbers 1 and 3, ACE. They're all just grind questions that you just got to do for practice. And from number 6 on, it's starting to apply it into questions like this, where not only do you need to know the math, but also know why the heck am I doing this? What is it even helping me with? Okay? Any questions that you might have right this minute for this question? It might be a little overwhelming, so you don't have much questions right now. You don't even know what to ask. I'm going to stop the recording here. I'm going to stop the lesson here, which means I have to keep you here for a full hour and 20. During that time, as I always offer you, I will be here taking whatever questions you want. My hope and my dream is that you will use that time efficiently, that you will try some of the homework questions since you have to be here anyways. You can totally take a break, I understand, but please don't squander the hour and 20 you have, because the future you will hate you for it. Okay? Any other questions before we call it a day? All right. Take a break. Your brain needs it. Your brain will thank you for it. But then come back and let's do some work.